This video is about how to graph the function log of x. Here we have the function negative 2 log times negative x plus 2 plus 1. And say we didn't know what the parent function was, and we need to know that in order to graph a function. So we need to be able to identify all these transformations and take them out, and whatever is left is our parent function. So here we have a negative, which indicates a vertical reflection, which is a reflection across the x-axis. And 2 indicates a vertical stretch, so stretching our graph kind of up, like vertically. The negative inside the parentheses in front of the x indicates a horizontal reflection, so across the y-axis. The plus 2 is a translation left 2 units, and the plus 1 is a translation up 1 unit. So if we take all those transformations out, we are left with log of x, which is our parent function. Now if you were to type that into your calculator, you would get something that looks like this. This red line is our function, and this dotted pink line is our asymptote, which is the y-axis, or the line x equals 0. An asymptote is a line that the function gets so close to touching, but it never actually reaches it. It just gets closer and closer and closer, but never touches or crosses it. So in order to graph this, I'm going to go ahead and draw our parent function on this board. You can go ahead and type it in your calculator if you want more accurate coordinates, but this is a pretty good guess. Okay, so once we have that, we're going to go ahead and apply our first transformation, which is a vertical reflection. So we're taking this red line and flipping it upside down. If you notice, our asymptote is still the same. It's still this line, x equals 0. The next thing we're going to do, well, the vertical stretch is next, but those are easier to do last, so I'm going to skip ahead to the horizontal reflection, just taking this yellow line and reflecting it across the y-axis. So if I do that, it will look something like that. And the asymptote is still the same. Now we're going to have a translation left 2 units and up 1 unit. The left 2 units changes our asymptote from the line x equals 0 over 2 to the line x equals negative 2. So this one is no longer the asymptote. And moving it up 1 just moves our graph, our function up 1. So it will look something like that. But we still have to apply this vertical stretch that we skipped earlier. So I'm going to go ahead and erase this and stretch it out just a bit. So it might look a bit longer. So it'll look something like that. And our asymptote is still x equals negative 2 after the vertical stretch is applied. So once we have that, this is our parent function, this is this function. We're going to go ahead and discuss its characteristics. We're going to start with range and domain. Domain talks about the x values, and range talks about the y values. So the domain equals x is less than negative 2. And that means because the asymptote is negative 2, or x equals negative 2, therefore it can no longer, well, x can't cross or equal to negative 2. It just gets closer and closer and closer, but it can go infinitely negative, but it cannot go past negative 2. And the range is y equals all round numbers. This is what this means. That means even though x can't go past a certain point, y can go infinitely both ways. After we discuss that, we need to go ahead and discuss the end behavior. The end behavior just talks about what happens to x when y does something, or what happens to y when x does something. So as x approaches negative 2, which is the asymptote, y approaches infinity. So as x gets closer and closer to the asymptote, y keeps going up and up and up. Also, we need to discuss what happens when x approaches negative infinity. X can go infinitely that way because there's nothing stopping it that way. And as x approaches negative infinity, y also approaches negative infinity because y goes down. So that is how to graph the function log of x.